Alrighty, so we're going to continue looking at position versus time graphs and also velocity versus time graphs. And we're going to see, can we convert a position versus time graph into a velocity graph? So that is to say, if we're given a graph of the position of an object over time, can we understand how the object's moving? And then can we make a graph which gives the information of the velocity of that object as time progresses? And in fact, we can. It's not that hard, as long as we understand the rules. So here, I have an example. On the left is a position versus time graph, already written out. And my job is to fill out the velocity versus time graph for this example. Now what I'm going to do is, before I fill out the velocity versus time graph, I'm going to try to explain the story of the position versus time graph. I'm going to say, by reading that graph, what the object is doing. So if we look at the position versus time graph, first of all, at t equals 0, the object's at the 0 location, let's say, and it starts to move in the positive x direction because it's going upwards in this graph. So it's moving in the positive x direction, whatever direction that means. And we can see that after 2 seconds, it has gone a distance of 2 meters. So let's look at the 2-second stuff. This is just a little shorthand for saying the position, how does the position change within the first 2 seconds? Well, we remember how to do this. The previous video we talked about, given a graph, we could either look at the slope or we could look at the area. And we discovered that if we're given a position versus time graph, if we look at the slope, that tells us the velocity. Because the slope is rise over run, and for this particular graph, rise means the change in the position, run means the change in time. So I know velocity is change in position over time. So for the first 2 seconds, how much did my position change? I got to the 2 meter position. I started at the 0 position, so that's the change, 2 minus 0. And how long did it take? It took 2 seconds to do that. So for the first 2 seconds, my object traveled in a positive x direction with a velocity of 2 over 2, which is 1 meter per second. All right, fine. Now what happens? Then it goes from 2 to 3 seconds. So I'll just say x by the time it gets to 3. What's the velocity of the object during this interval? Well, in that 1 second, from the 2-second mark to the 3-second mark, we can see the object started at the 2 meter position and ended at the 2 meter position. So final is 2, minus initial is 2. How long does it take to do this? This interval is 1 second long. So we get a velocity of 0. All right, next. We're going from the 3-second mark to the 4-second mark. Okay, so let's call this the 4-second interval. We get down to -2, so the final position is -2. We start at the 2 position. And how long is this interval? From the 3-second mark to the 4-second mark is 1 second. So -2 over 1 is -4 meters per second. All right, then the next section, we're going from the 4-second mark to the 6-second mark. So call this x6. What are we doing? Well, We end up at the 6-second mark, we're at -2. We started at the -2 position. And the time during this interval is from 4 to 6, which is 2 seconds. So -2 minus -2 is 0. So our velocity there is 0. That is to say, the object just stood there for 2 seconds without moving. All right, next section, we're going from the 6-second mark to the 8-second mark. So call this x8. Our final position, we get up to the 0 meter mark, and we start at the -2 meter mark. And how long is this section? From 6 to 8 is 2 seconds. So the velocity, 0 minus -2 over 2, is 2 over 2, which is just 1 meter per second. And then our last section is from the 8-second mark to the 10-second mark, so call this x10. What do we have? We end up at the 4 meter mark. We start at the 0 meter mark. And how long is this section? From 8 to 10 is 2 seconds. So this velocity, 4 minus 0 over 2, is 2 meters per second. All right, good. So I've got all my velocities laid out for each interval. Before I go ahead and fill in my velocity versus time graph, I'll talk my way through the graph, the position graph, as a story. I would say the object starts at the 0 meter mark, here, travels in the positive x direction to the 2 meter mark in 2 seconds. From there, it spends 1 second staying in place. Then it turns around, travels back in the negative x direction, all the way till it reaches the -2 meter mark, and it takes 1 second to do that. At that point, it stops and stays in position for 2 more seconds. Then again it turns around, this time traveling in the positive x direction until it reaches the starting point, the 0 meter mark, and it takes 2 seconds to do this. At which point it then speeds up and goes from the 0 meter mark up to the 4 meter mark in the positive x direction, taking 2 seconds to do that. So that's what you should be able to do. You should be able to look at this position versus time graph, look at the data, see how the lines are drawn, and be able to tell, kind of picture in your mind what this object is doing. Furthermore, you should be able to take that information and actually draw in, or first of all, calculate the velocity for each interval. And then what we're about to do now is draw the velocity versus time graph given that information. So here we go. We're going to start at the velocity versus time graph. We say, okay, for the first 2 seconds, from 0 to 2, we have a velocity of 1. Okay, so from 0 to 2 seconds, we have a velocity of 1. There it is. Then, from the 2 to the 3-second mark, we have a velocity of 0. So, there we go, velocity of 0. Then from the 3 to the 4 meter mark, 4-second mark, we have a velocity of -4. So this drops all the way down and goes for 1 more second. Then from the 4-second to the 6-second mark, we have a velocity of 0. So this line goes back up to 0 and lasts until we get to 6. Then from 6 to 8, we have a velocity of 1. So we go back up to 1 again. We stay there for 2 seconds. And in the last 2 seconds, from 8 to 10, we have a velocity of 2. This moves up to the 2 meters per second. And there we go. There is our velocity versus time graph based on the information given in a position versus time graph. Obviously, drawing the velocity versus time graph is easy once you have all of these calculations done. So, the most important thing is, can you calculate the velocity of the object from its position versus time graph? And indeed you can. All you need is that equation there. That tells you find the slope for each interval. The slope tells you the velocity. And remember, slope is the change in the y, the rise, over the change in the run, the x. So y over x. Position over time. Okay, now we want to do the opposite. Let's say we're given a velocity versus time graph, and we want to calculate the position versus time graph from it. So, let's see. Let's say we have, here's velocity versus time graph. 1, 2, 3. So here's 1, 2, 3, minus 1, minus 2, minus 3, 2, 3, 4, 5, 6. Okay. 2, 4, 6. And let's say the graph looks something like this. All right. So there we have a velocity versus time graph. Now, I want to draw what's the position versus time graph for this. Six, 4, 2. All right. So let's say 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. All right. So how do we do this? Well, first let's read the velocity versus time graph. So when I look at this graph, I say, okay, so for the first 2 seconds from 0 to 2, what's my velocity? My velocity is -1. Okay. Then from 2 to 3 seconds, my velocity is 2, positive. Then from 3 to 5, I have 0 velocity. And then from 5 to 6, I have a velocity of +1. What one can do when trying to go from velocity to position graph is, again, remember, we're either going to be looking at slopes or we're going to be looking at areas. Let's consider the slope. What would the slope give us? Well, the slope, again, is rise over run, which is a change in the velocity, that's the y stuff, over the change in the time, that's the x stuff. So change in velocity over time, do we know of anything in kinematics, which is the change in the velocity? Yes, that's equal to the acceleration. So, if I wanted to figure out how is this object accelerating, I would use the slope. Just like before, in this section, how the position changed in time told me about the velocity. If I do the slope of the velocity, that would tell me about the acceleration. And I can make an acceleration graph exactly as we did the last problem. However, that's not what I want here. I don't want the acceleration, I want the position. So, what about area? What does area tell us? Well, area is like length times width, right? So x times y. So that's velocity times time. Do we know of anything in kinematics which is the velocity times the time? Well, if you remember, velocity is the change in position over time. And if I just multiply by time on both sides, I find that position is velocity times time. So if you know how fast you're going, 5 meters per second, and you know it took 2 seconds to get there, you'd say, okay, 5 meters per second times 2 seconds, I traveled 10 meters. So the area of this graph, or each little interval, will tell me about how I changed my position. I know the velocity, I know how long I'm traveling at that speed. That tells me how far I'm going. So that's what I'm going to do. I'm going to say, okay, let's look at this first interval. From the 0 second to the 2 second mark. I know I'm traveling -1 meters per second. So what's the area of this little box? Well, it's -1 is the height, 2 is the width, so -1 times 2. I have a change in position of -1 times 2 is -2 meters. So my first little interval, I'm going to change from wherever I start, I'm going to change downwards 2. Now let's look at the second interval. Second interval, I go from the 2 to the 3 second mark, so that's 1 second on the x-axis. And the height is +2. So this delta x is going to be +2 times 1 second. 2 times 1 is 2. So this says wherever I just ended, it's going to take me 1 second and I'm going to change 2 meters in the positive direction. All right, now let's look at the 3 second mark to the 5 second mark. So from here to here, what's happening there? We do the same thing. What's the x-axis? 3 to 5 is 2 seconds. What's the height? I'm at 0 velocity, so 0 times 2. I change by 0 meters for that interval. And then the last interval we have here is from 5 to 6. That's 1 second long. So 1 second times the velocity for that interval is +1. So +1 times 1 is 1 meter change. And now I have all my intervals done. So just like in the previous example, here, we did all these calculations to calculate the velocities for each interval. Here, we're looking at the areas to give us the change in position for each interval. Once we have this information, filling out this graph is going to be nice. This is how we do it. Look at the first interval from 0 to 2 seconds. So now in the position graph, from 0 to 2, what do we know? Well, in that time, I have to go from wherever I start. Let's assume I start at 0. I have to end up changing 2 meters downwards from it, because delta x is -2 for the first one. So if I start at 0, I must end up at -2 by the end of the interval. So the interval ends at the 2 second mark, so right here is where I should end up. And then I just draw a diagonal line to connect them. So there we go. There's my first interval. Now from 2 to 3 seconds, what am I told? Wherever I'm starting from, I'm going to change by a factor of +2. Okay, so that means I'm starting here at -2. I'm going to go up 2, so I'm going to end up at 0. And that happens by the time I get to the 3 second mark. So I need to end up right there. At the 3 second mark, I go up 2 from where I am, which just happens to mean I end up at the 0. Okay, that's fine. Now what? Now from the 3 second mark to the 5 second mark, I'm told I don't change position at all. No change in position. So I just ride where I'm sitting until I get to the 5 second mark. There we go. And then from 5 to 6, I change upwards 1 meter. So wherever I'm starting from, which is right here, the 5 second mark at 0, I go up 1 by the time I get to the 6 second mark. So here's that point, and I just connect it. And there we go. I've now drawn the position versus time graph from my velocity versus time graph. which isn't so bad. The important part is doing your calculations ahead of time for each interval. Here, if I want to go from velocity to position, I calculate the area. Height times width, or length times width, however you want to say it. Y times x. What does that tell me? That tells me how much do I change. Notice it doesn't tell me where I go. For instance, for the first interval, I got a delta x of -2. What that means is wherever I'm starting from, I'm going to go down 2. That doesn't mean I necessarily go to -2. It happens that I did go to -2, but that was a coincidence. And to see it, look at the next interval. The next interval said delta x is +2. That doesn't mean that in the next interval you reach the +2 mark. What it means is you're going to change your position from where you're starting up 2 positions. So here I started at -2, and I have to go up 2, which means I'm going to reach the 0 meter mark. And it takes me the interval amount of time to do it. Okay, so don't get that confused because it is an easy mistake to make. These intervals are telling me how I'm changing, not the actual value I'm going to. In the previous attempt, when we did the slope to find velocity, that was the actual velocity, not the change in the velocity. But when you do the area, you're finding the change in the position. Okay, and like I said, the more examples you work on, the more second nature this is going to become. The good thing is, at the end of the day, given a problem on a test or a quiz or homework, you have 2 options. You're either going to be looking at slopes, which will tell you y over x, rise over run, or you're going to look at areas, which is going to be y times x. One of those 2 will give you the answer. Given position versus time and you want velocity, it turns out you use the slope. For this example, we were given the velocity and we want to calculate position. We had to use the area to do that. Now, just for future notice, because it works exactly the same, we're told, given a position, if you want to get velocity, you do the slope. And given the velocity, you want the position, you do the area. Well, it also works if I'm given the velocity and I want the acceleration, you do the slope. Given the acceleration graph, if I want the velocity graph, you do the area. It's exactly the same process. And I'm telling you this because you may see a homework problem or a quiz problem where instead of giving you position and wanting velocity, I gave you velocity and I want acceleration. Don't freak out because the variables are different. Just pretend like it's position and velocity. The method is identical. If you're given a velocity graph and I say, fill out the acceleration graph, you do just what we did in this first problem. Find the slope for each interval. That slope will tell you the acceleration for that interval. Or vice versa, if I give you an acceleration graph and I say, hey, find a velocity graph, do what we did in the second problem. Calculate the area for each interval, and what that'll do is that'll tell you the change in the velocity for each interval. Okay? Just forget that it says v and a instead of x and v. The variable name doesn't matter as long as you know how they're related, either by slope or by area. All right, the other thing to note is, let's say in some weird way I gave you a position versus time graph. You may have something that looks like this, like we've been doing, and then you might have something that's curvy. So this part here, it's curvy. What does that mean? That means you don't have a constant slope. If you don't have a constant slope, physically that means you don't have a constant velocity. What does it mean to not have a constant velocity? It means you're accelerating. So, if you see either you're looking at references online, other people working examples on YouTube or whatever, and you see graphs where there's a curve instead of these nice straight lines, all it means is this object's accelerating somewhere. Okay? I won't ask you, here's a position graph, give me the acceleration, because we don't know how to do it. But what you should be able to say is, looking at this graph, I know there's an acceleration somewhere because of the curve. Okay. All right, so that's all for this video. I think we have covered all the theory for these position versus time and velocity versus time graphs. I'm going to post kind of a worksheet with a whole bunch of examples I'm going to want you to work through. So be on the lookout for that on Canvas. Practice these very, very much. You're building inside your mind the conceptual ability to understand these systems. And that's important. I want you to build the conceptual stuff before we focus on all the math. If you're good with the conceptual part of physics, you're going to be a powerful person. Those people who don't have the conceptual down must rely on pure mathematical skill, and that's very difficult to do. So master this conceptual stuff, be able to look at these graphs and understand in your mind, how is this object moving around? How are these things related? Later, we're going to have problems where we do some heavy-duty equations and calculations. But if you have this down, those calculations will be much easier later. All right, so I wish you luck. Hope this worked out well. And as always, if you have any questions about this stuff, please email me. Send me pictures if you're working through these problems and you're getting stuck. We will be having a test within the coming weeks. And it's not good to wait till the last minute to start asking questions, because these topics take a while to learn. You have to learn them over time. And the longer the time span is that you're learning them, the more fundamentally you're going to learn them. If you try to memorize everything in the last 2 or 3 days, you might do well on a test, but in a month you don't remember anything. And especially next semester or the semester after. So, work these problems through when you have some time. I know you have other classes, but it's important. Practice these problems. If there's something you're not understanding or you're getting different answers than I am, feel free to email me. Say, look, this is what I did. Can you tell me why I'm getting a different answer than you are? And I'll be happy to answer that for you. So practice and keep looking on Canvas for quizzes, homework problems, things like that. Till next time.